Me, please. What A equals? What was your first A equals? Someone raise their hand and tell me. Luke, what'd you get?
A is equal to -1 plus root 5 over 2.
And what did someone get for B? What did someone get for B for that first one? Tyler, what'd you get? Tyler.
1 plus root 5 over 2.
Nope. Will?
3 minus root 5 over 2.
3 minus root 5 over 2. Correct. And what did you guys get for, therefore, when you did this out, when you simplified it all out the entire time, the entire way, not the golden ration, what was the golden ratio equal to? Someone knew. Tyler.
1 plus root 5 over 2.
Yes. The golden ratio was 1 plus root 5 over 2. And that was all of this. You did all of this. This was A over B right here, right? And you started with A plus B over A is equal to A over B. And also that A plus B was equal to 1. So you used this knowledge and you pumped it in and you got that out right there. A was that, B was that, and the golden ratio, which is A over B, was equal to that. So the question for part 4, which you can come to a conclusion, but you need to prove it, you need to justify it fully, was what happens if A plus B is equal to some constant C? Instead of 1, what happens if it's equal to C? The ratio still stays the same. A plus B over A is equal to A over B. So what happens to the picture? Essentially, instead of it being a length of 1, like this is A and this is B, and this is 1 right there, what's the length? C instead. That's all we're doing. We're changing it to C. That's it. So this original ratio stays the same, but what's A plus B equal to? So C over A is equal to A over B. So A squared is equal to what? To CB, right? But what does C equal?
B plus A.
What does C equal? A plus B, right? What does B therefore equal? C minus A. So let's take that and plug it in right there. And we get A squared is equal to C times C minus A. We did that because how many variables do we now have? Nope. How many variables do we have? Nope. 1. What is C? Constant. Is it a variable? No. How many variables do we now have? 1. This is therefore what kind of an equation? That's a quadratic. When we solve quadratics, we set them equal to 0. A squared plus AC minus C squared is equal to what? 0. This is a quadratic. We're trying to find out when this equals 0. It's challenging to factor this. You tried to factor before, but what did you have to use to solve the quadratic before? Quadratic formula, right? The quadratic formula applies to ax squared plus bx plus c is equal to. The only tricky part about this is these are not the same a and c values. They are different. In this case, this a value is just the coefficient of what's being squared. The coefficient of what's being squared. What's the coefficient of what's being squared? 1. So in this case, for the purpose of this formula, a is equal to 1. What does b equal in this case? C. What's the coefficient of A? C. What's the coefficient of A? It's the coefficient of the thing to the first power. And what's the last value here? Negative C squared. In this case, it's C squared. For in this quadratic right here, A is the coefficient of x squared. Here, I'll rewrite it for you. X squared plus CX minus C squared is equal to 0. Solving that is the same thing as solving that. Does it matter what we call the variable? No. You guys get accustomed to what being the variable. X. I could literally ask the same question, but instead of using X, use A, and you guys would do worse if I used A than if I used X. For the sole reason that you're more comfortable with X, and therefore it's harder for you to see certain things. Does anything change? Could I call the variable Bob if I wanted to? It's just the A in this case is just the coefficient of x squared, B is the coefficient of x, and C is the constant. So in this case, A is 1, B is equal to C, and C is C squared. This is not the same C. Does everybody understand that? So it's, in this case, A is going to be equal to negative C, right here, plus or minus the square root of C squared minus 4A C squared all over what? 2 times 1. Yes, this should be a negative c squared because look, the constant is negative c squared. Is everybody with me so far? The thing that is most challenging about this, Lee, sit up, is that the labeling gets overlapped. There's two different a values, there's two different b values, and there's two different c values. They're not the same thing. They're not the same thing. In the quadratic equation, a is the coefficient of x squared. B is the coefficient of x. And c is the constant, right? But in this case, we're already using a and c. I understand why that is annoying. I understand that. It was a poor choice. But does it change anything about the quadratic formula? No. Now you just need to simplify this. A is equal to negative c plus or minus. What goes under here? 5c squared, because it's one of them and you're adding 4 of them, all over what? 2. So a is going to be equal to negative c plus or minus the square root of 5 times the square root of c squared all over 2. What's the square root of c squared? Negative c plus or minus c root 5 all over 2. And what can I factor out of the top? I can factor out what? A c, yeah, exactly. So this is c times 1 plus or minus the square root of 5 all over what? 2. Do you agree with that? Mm-hmm. Now, we know that a has to be positive or negative. Mm-hmm. Does a have to be positive or negative?
Positive because
it's a length, right? We have two answers here, plus or minus. Which one are we going to take? The plus, because if we do negative 1 minus root 5, we're going to end up with a negative number. Root 5 is greater than 1, so when you add it to negative 1, you get a positive. So a is therefore equal to c times negative 1 plus root 5 all over 2. We just found a. What else do we need to find? B. What was our relationship? A plus b was equal to c. So we know that c times negative 1 plus root 5 all over 2 plus b is equal to c. All I'm doing is I'm substituting for a, right? I'm trying to isolate b, so b is equal to c minus this thing, right?
Right.
Okay, well, that's good. Minus that, right? What can we factor out of both of those? C times 1 minus negative 1 plus root 5 over 2. How do you combine fractions? Common denominator, right? So this is b is equal to c times c over c minus negative 1 root 5 plus root 5 all over 2. Sorry, not c over c. 2 over 2. Sorry. So what does that turn into? C times... What's 2 minus negative 1? 3 plus root 5 all over 2. So there's our b value, right? 3 minus, thank you, yes. So there's our b value. Our golden ratio again was what? A over b, right?
Yep.
So what was a over b going to be? Well, a was, what was a? C times what?
Negative 1.
Plus root 5 over 2. And what was b equal to?
C times 3 minus root 5 over 2.
What cancels?
The C is the same.
The c cancels, this cancels, right? And you're left with the same ratio. And we know that that simplifies because you already did that math. What is that equal to?
1 plus root 5 over 2.
Which is the
Golden ratio.
So does it matter how long the rod is?
Nope.
It does not. It does not. Cool, huh?
Yeah.
So we did all this work to talk about the golden ratio. What's one question you might ask at this point?
What does this pertain to in real life situations?
Absolutely. So essentially, so say that what do you, when you say this, what do you mean?
What is the golden ratio? How is it used in life situations?
Yeah. Where does the golden ratio occur in?
Right. In the universe.
In the universe. I like that. I was thinking of nature. Universe is better.
Yeah.
I like that a lot. That's a similar word.